Let's consider a projectile question. Let's say we have a cliff overlooking some kind of valley, and the cliff is 52 meters high. And we are launching a projectile from the top of the cliff at an angle of 30 degrees to the horizontal. And let's say we're launching that projectile at 42 meters per second. What kind of questions could I ask about that? Well, one of the most important questions people usually ask is something like, well, where on the ground does it hit? How far from the base of the cliff would that projectile hit? And another important question they might ask, how long did it take? Well, when dealing with a projectile question at an angle like that, the first thing I look to find out is the initial vertical velocity and initial horizontal velocity. To do that, I'm going to need some trigonometry. So I want to find out that and that in terms of velocity. Now, this is going to be my velocity in the y direction, be my velocity in the x direction. So let's say I'm looking to solve for my velocity in the y direction. From the angle, that's the opposite side, and that's the hypotenuse. So I'm going to be using the sine. Sine of my angle equals the opposite side over the hypotenuse. And in order to solve that, the initial velocity in the y direction, I would times both sides by 42. And let's see what that is. 42 sine 30 ends up being 21. So the velocity in the y direction is 21 meters per second up. Now, the other one, the Vx, is going to be cosine 30, because this time I'm using the adjacent side in the hypotenuse, is equal to Vx over 42. And once again, to solve for the velocity in the x direction, I'm going to times both sides by 42. So Vx would equal 42 cos 30, which is 36.4. So now I have the initial velocity in the x direction and the initial velocity in the y direction. I'm going to make a chart in the horizontal direction and the vertical direction of all the things that I know. Now I could find out velocity initial, velocity final, acceleration, displacement, and time for both of these. We're going to see which of these variables I can identify. Let's look at the horizontal direction. The horizontal direction, my initial velocity we calculated was 36.4 meters per second. Now, the horizontal velocity in a projectile stays the same the entire journey, assuming that there's no air resistance, which would make my final velocity 36.4 meters per second. Now, if my initial velocity and my final velocity are the same, that makes my acceleration in the horizontal direction to be 0 meters per second squared. Do I know my displacement in the x direction? No. Do I know how long it took to go in the x direction? No. So, let's take a look at all the stuff I know for my vertical journey. My initial velocity in the vertical direction was calculated to be 21 meters per second. Now my final velocity, when it hits the ground, I don't know. Do I know the acceleration in the vertical direction of a projectile? People tell me that it is negative 9.8 meters per second squared. That's because any object under the gravitational field of the Earth will fall at the same rate. Do I know my displacement in the x direction? 52 meters. But since I started at the top and went to the bottom, my displacement from where I start to where I finish is actually a negative 52. Not meters per second, meters. Do I know the time it takes it to fall? No. But do I have enough information to find these things out? Let's try finding the final velocity if I know the initial velocity, the acceleration, and the displacement. Which of my formulas would I pick? Vf squared equals Vi squared plus 2AD. My Vf, I'm trying to find. My initial velocity, 21 squared plus 2 times my acceleration, negative 9.8, and my displacement, negative 52. Why do you think I took the square root of that? Because I was trying to find velocity final, not velocity final squared. So I took the square root of both sides. I should be able to put that straight into my calculator. So the square root of 21 squared minus 2 times negative 9.8 times negative 52. Now, it says non-real answer. When I look at my formula, I accidentally put in a minus instead of a plus. Let's see if that helps. So my final velocity was 38.21. Now, remembering that every time I take a square root of something, I get a plus and minus answer. What direction do you think the velocity would be when it's hitting the ground? The velocity when I'm hitting the ground would be going down. So it's actually negative 38.21 meters per second. From that information, can I find my time? I'll pick Vf equals Vi plus At. My Vf, negative 38.21. My Vi, 21. My A, negative 9.8. And my T is what I'm after. To get T by itself, I take the negative 38.21 minus the 21 and divide by negative 9.8. Let's see what I get. Double check my formula to make sure I didn't make any mistakes. 6.04 seconds. Now, the time in the vertical part of my journey would be the same time for my vertical part of my journey. So I know the time it took the projectile to hit the ground. The next question I need to figure out is how far sideways it was when it hit the ground. I'm going to use which formula? D equals VIT plus 1/2 AT squared. My D is what I want. My VIT, the VI was 36.4. My time, 6.04 plus, now a lot of people say that goes to 0. Why is that? Well, because if my acceleration in the horizontal direction is 0, then 0 times any number is going to give me 0. So displacement in my y direction is my time times my initial velocity in the x direction. This projectile is 219.9 meters from the base of the cliff. I hope you found that helpful.